Welcome to Step by Step STEM. This video I'm going to show you everything you need to know about the quadratic equation and how to use it. So the first thing about the quadratic equation is that it can be used to solve any quadratic equation that's in standard form. As you see here, we have three coefficients. We have a, which goes with the x squared term. So whatever term has the x squared is your a term. It doesn't matter if it's written differently. B goes with the x term. Whatever term is connected to a single exponent x, that is going to be your b term. And whatever the constant is, there's no x value attached, is your c term. Now, once you figure out these terms, you can go ahead and plug it into this big formula. So, if you're just seeing the quadratic formula for the first time, it's probably the biggest formula you've seen in math class to date, and it looks super scary, but I'm going to explain it to you, and it's not that hard. So as you see here, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So, when you look at the quadratic formula, you will put your b term here. Notice it's negative, which means whatever your b term is in this formula, you're going to put the opposite sign right here. Then it's plus or minus the square root of b squared. Anything squared is positive, so you don't really have to worry about the sign. But b squared minus 4 times a times c. So 4 times a times c all over 2a. A few more things to know before we get into an example is that this plus and minus symbol means that we could get two possible solutions, and also everything under this square root right here is called the discriminant, but we'll talk about that in a second. So the first example is shown here. If you're coming from the short on my channel, you would have already seen it, but let's start here. So let's identify our a, b, and c. So what did I say earlier? The a coefficient is attached to the x squared value, so we got to look at the x squared right here, and the a value is 2. So a equals 2. B, so be careful, it's not 3, it's negative 3. You have to keep the sign. And the c value right here, there's no x term attached, so it is negative 2. Alright, so now that we know our coefficients, we can go and plug them into the formula. So the first term is negative b. So we have negative, and then b is negative 3, plus minus square root of b squared, so negative 3 squared, minus 4 times ac. A is 2. It's all over 2a, so I'll put that down there, and c is negative 2. Going ahead and solving this more, the negatives cancel, so we get 3 plus minus the square root of negative 3 squared. Anything squared is positive, so we're going to get 9. And then negative 4 times negative 2 is 8, times 2 is 16, it's positive 9 plus 16, all over 2 times 2, which is 4. X equals 3, plus or minus 9 plus 16 is 25, root 25 over 4, and we know that root 25 is 5, so x equals 3 plus 5 over 4, and x also equals x also equals 3 minus 5 over 4. 3 plus 5 equals 8, over 4, and 3 minus 5 equals negative 2 over 4. And if you want to write them as decimal numbers, we have x equals 2 and x equals negative 0.5. Now what does this mean? This means these are the points where the graph intercepts the x-axis, or the x-intercepts. So if you have a graph which looks like this, and we have 1, 2, 1, 2, then that means that the quadratic equation shown before intercepts the graph here at x equals 2 and here at x equals 0.5. We know quadratics have a shape like this. Okay, let's get into some common mistakes that people make when it comes to the quadratic formula. So first, let's say your teacher gives you something like 3x plus 2x squared plus 5 equals 3. Now, common mistake is thinking that this is B and this is C. Well, this is not the case because, as I mentioned earlier, the A term is not necessarily the first term, the B term is not necessarily the second term, and the C term is not necessarily the third term. In this case, A would actually equal 2, B would actually equal 3, and C, if your teacher gives you something like this, make sure the equation always equals 0, so you have to bring the 3 over. It becomes negative 3 when it crosses over the equal sign. 5 minus 3 is 2, so C equals 2. Another mistake people make is forgetting the plus minus and either doing only plus or only minus. You need to remember to do both because there could be two solutions. Another error is separating the negative b from the fraction and writing something like negative b plus or minus the square root of b squared minus 4ac over 2a. This is wrong. You have to make sure everything is over 2a. Another error is calculating this wrong, this term right here. You have to make sure to distribute the negative sign and calculate it correctly, or else your answer will be wrong. And the final error that I would see is if your teacher wants you to simplify the answer, don't just leave it like 8 over 4. You have to change it into 2. Now earlier I mentioned the discriminant, which is everything that's under the square root. And now we're going to talk a little bit more about it and why it's important. So if you want to quickly check your answer and see if it's right, you calculate the discriminant. And if the discriminant is greater than 0, then therefore you will get 2 real solutions. If the discriminant equals 0, therefore you will get 1 real solution. And if the discriminant is less than 0, then therefore no real solutions. So we'll explain why in a second. Alright, let's get into y. So remember that the discriminant is under the square root, so it's b squared minus 4ac. So if it's greater than 0, that means that under the square root is a positive number, and you'll get 2 real solutions. If it's equal 0, that means it's root 0, which is 0, and you'll get 1 real solution. And if it's negative, then you'll have root of a negative, which you can't do. You can't take the square root of a negative number, so therefore there's no real solution. Now we're going to get into 3 examples to really highlight this idea and let you test your knowledge. Alright, so the first example is x squared minus 5x plus 6 equals 0. We will start by finding the determinant, b squared minus 4ac. So, b is negative 5 squared minus 4 times 1 times 6, which equals 25 minus 24, which equals 1. And since this is positive, then we know we're going to have 2 real roots. So let's check that. We're going to write x equals negative b plus minus square root b squared minus 4ac over 2a. And then we plug in our values. We have 5 plus minus square root 5 squared minus 4 times 1 times 6 over 2a, which is 1, equals 5 plus or minus root 1 over 2, which equals 5 plus 1 over 2 and 5 minus 1 over 2, which equals 6 over 2 and 4 over 2. And then we get 2 answers of x equals 3 and x equals 2. Okay, example 2 is x squared minus 4x plus 4. We're going to find the determinant, b squared minus 4ac. b is negative 4, and we're squaring that, minus 4 times 1 times 4. 4 squared is 16, and 4 times 4 is 16, so minus 16 equals 0. So we're going to get 1 real root. So let's check that now. So after plugging all that in, you can see that we get x equals 2 as our one and only answer. And finally, question 3 is x squared plus 2x plus 5. So let's find the determinant, b squared minus 4ac. b is 2. 2 squared minus 4 times a is 1. c is 5. 2 squared is 4. And then minus 4 times 5 is 20. Minus 20 equals negative 16. Now, since negative 16 is less than 0, therefore we have no real roots. If this video helped you in any way, please make sure to like, comment, and subscribe for more STEM videos. We'll see you guys again soon.